there were 3 different circuits we talked about. Different types of circuits we can use to couple our signal from our input between the stages to our output. First one was this RC coupling. And how do we know? There's a capacitor linking the 2 stages together. So some things you got to know about it: frequency response, temperature stability. What do we say about frequency response with this one? Yeah, the frequency response is good at higher frequencies, and poor at low. And don't forget, each one of these, especially the RC, this type, the transformer coupling, has a specific range or bandwidth, doesn't it? Or operating bandwidth, yeah. And I told you, you don't have to memorize what the hell the bandwidth is. Just realize that you need to understand or just know what the characteristics are. Good, high, poor, low. And frequency response just means what? What does that term mean? What does it actually mean?
How the circuit will act in certain frequencies.
Yeah, that's all it means. Frequency response to this circuit, or this circuit, or this circuit. How the circuit's going to respond or react to different frequencies. That's all it means. It's response. How's it going to act or react? Yeah, we got a capacitor is probably going to react. Be the more correct term, transformer, because there's coils, probably going to react. Yes. This one, direct coupling, it's going to do what to different frequencies? They don't care. There's no reactive components to deal with. So back to this. Good, high, poor, low. Temperature stability. We already know what that is. How can we tell what the temperature stability is of this circuit just by looking at it? Yeah. We can say it's good or really good, very good, because each stage has its own voltage divider bias, the base, with emitter feedback. Hello. From the bias stabilization class, we determined that that's a pretty good temperature stability if that is so. Because when temperature increases, who remembers what happens to the base emitter junction? Or base emitter, okay, go ahead.
The resistor limits the amount of voltage that it applies in the junction. And that way it doesn't let, even though it's letting more current through, it's going to channel that current so it's not going to trip the junction. And let too much current through it overheat.
Okay, that sounds pretty good. Put it the same way, but in different words. If temperature increases, that voltage of the emitter resistor is going to do what? No, the right here, this part right here. It's going to increase because, remember, when temperature increases, everything increases. That's going to affect the emitter current. So if I have more emitter current, and I, Ohm's law, times, I'll say RE2, same value of the resistor, that's not going to change. Bigger times same is going to give you bigger. Voltage drop is going to be bigger. So if I apply a larger voltage on N-type material, it's going to compensate, make it less forward biased for increase in temperature. And if you understand that much, that's pretty good.